Well, good afternoon, ladies and gentlemen. I have the honor to chair this panel on machine learning techniques for cultural heritage preservation. We are all but one people present here. Professor Asteris will not be with us. Professor Doulamis from National Technical University is representing the side of engineering and informatics. Professor Ronzi from Milano, as far as I understand. He will explain his view. I like his view. It's very strange in my point of view. Mrs. Pentinalli Biscaretti from Milano as well, an architect dealing with conservation and using digital tools. And Professor Foudos from Ioannina, he is a computer science specialist, maybe the only one who is purely computer science guy. So I tried to inaugurate, let us say, the discussion by showing some slides. Let me try to find them. First slide, please, πρώτη διαφάνεια. Okay, here are the names, you know the names, I have already mentioned them. Please, the next, επόμενη. I can't do that. Ωραία. Okay, I tried to, we have had another session before the lunch dealing on digital heritage and digital tools. And I learned there that besides the digital twins, people are talking on other variants of history twins and memory twins. So I tried to gather here some technical notions, and in the discussion I will try to put some ideas where, for example, machine learning could be used, CAD, electronic design, and BIM, building information systems, or heritage BIM. We all know that it is the capturing of information, but how to choose from this information, for example, the very important historical or architectural details, or how to take them out in order to have a clean structural analysis model. These are questions which are very difficult to be solved unless you go and do it manually. And at this point, we hope that machine learning will help us. Finite element analysis, you could imagine, okay, this is structural analysis, this is stresses, strains, not a very fuzzy thing to be related with artificial intelligence. Despite of this, we are now developing methods trying to capture the information of stresses and strains from the testing or I put them directly in the solution method, in the finite element method, without adopting a mechanical theory, without having to answer the question, do I have an elastic or a plastic or a viscoelastic or a viscoplastic material? You can take directly the thousand of measurements and then try to interpolate between them by using artificial intelligence tools. People are calling this trend data-driven analysis. And this reminds me of the comment told in the previous session that Google is doing something, this interpolates, etc., but nobody knows what they are doing. I pose here a similar question. We try to abandon the classical mechanical theories and try to interpolate from the measurements. Okay, image processing, everybody understands what is it, but we want to have the CAD of a structure to use it further. We have to identify if it is possible, cracks, damages, etc. So multispectral image processing. And to go one step further, structural health monitoring. Okay, what happened to the structure? Is it safe or not? shall we intervene and do some rehabilitation work, etc., etc. All these things are covered nowadays under the term digital twins. But according to my view, this is nothing more than the next step of using parameterized models, identify parameters by taking thousands of information, Internet of Things and all these things, and doing possibly at the edge some pre-processing before sending this whole information through the 5G networks to the central computer. And of course, everything must be financed. That means advertisement, reuse, tourism is a driving force to help us do the real, let us say, engineering work. Okay, just to mention some words here, cultural heritage preservation. The group memory must be preserved. I think all these things have been discussed in previous session. Financial and sociological aspects are very important. In which society, in which content is the society, is the government able to finance, to support all these things. Of course, political influence of cultural heritage, this is very important, at least in Balkan area where several religions, several cultures are mixed and coexist, and depending on the situation, they can be used or abused or used. And just to take an inspiration from your work, do we have the right to forget sometimes if something is demolished? What means to have it in the digital replica? Maybe to study in some books, but I don't know. So I have to stop here because I took a lot of your time. And I will ask Professor Doulamis to start the discussion and his opinion about the topic.
Yeah, do you hear me? Okay, it's a very interesting topic, in my opinion, machine learning in cultural inheritance. All you have know about the research achievements in AI currently. And all you know, for example, how you can do things that you cannot imagine several years before. So what we have actually now, we have data, a lot of data, and this data is of low dimension and high dimension. It's multi-dimension, is 3D, is beyond extremely hyperspectral data. So you have, and why we have a lot of data? Because we have a lot of sensors. And we have a lot of sensors because we have low-cost sensors. And what we need technologies here to process and analyze this data in order to make a reasoning from this data. And this is the whole aspect, and there is a very important thing here in cultural inheritance, because nowadays we have, for example, data we can, with non-invasive methods, to see the material degradation of a building, of a monument, to find out with high precision the structural anatomy, to find out to have data of scanners with not only on the visible spectrum, but beyond this. And so all this data we need somehow to analyze. And here there is some issues in machine learning. what's the main problem? The main problem is that traditional machine learning makes an AI, makes data, okay? We have applied an algorithm and we have a decision. So this static approach, we need to reconsider nowadays. Okay, why? First of all, we need to have some explainability of why we have such a decisions from the machine. For example, we have data using, for example, UAVs and hyperspectral, and this, the AI, the machine learning, this automatic toolbox, I can say, suggests that there is a degradation on the material, there is something, a decision. How we trust this, and at which degree? And if this decision, this suggestion is not right, which is the responsibility and which is responsible for this? The AI expert who developed the machine learning? The cultural expert who cannot provide suggestion? The whole system? So there's some issues here. So one issue is the explainability. The second issue, which is very important, in how we trust the data itself. For example, we have several research funds, and we have experts, we say, to annotate the data. Okay, this is another chapter because annotation of the data is extremely arduous process. But okay, let's suppose that we have paid some people to annotate the data. These data are not of good quality. There are several errors, believe me. So if we have erroneous data, how we can train the algorithm? So one question is that this static process, this pipeline is somehow not so reliable, I can say. So it's another research open question. And there is another question open in this area is that about the data attacks. For example, perhaps some people maybe insert in the training set in the data erroneous, not by mistake, and by purpose data, in order to bypass the AI algorithm. So there is some issues over there. We have to select a lot of research in machine learning and decision making and in cultural heritage. So for this reason, actually there is an idea apart from explainability in the machine learning community regarding the so-called hybrid intelligence. Hybrid intelligence, what it means that we have this which, okay, makes some recommendations, and we have the user which somehow interact with the system, and the main issue here is how we can introduce dynamic algorithms, dynamic solutions to have adaptive adaptation in this process. So another research issue is hybrid intelligence. And the third issue, so we can say explainability, hybrid intelligence, is about how we make trustworthy AI, how we can trust the system, and at its degree, how we can develop a system which provides some probabilities, I can say, some indicators of how accurate this system is and at which degree. So it's not a process, you say, okay, we can apply machine learning and AI in order to process this huge amount of data we have nowadays. It's just some thoughts. Okay, let's continue then.
Thank you very much. I take this opportunity to mention another approach which is very popular among mechanical engineers. You talked about hybrid intelligence and how to mix the information from users with the automatic system. There is another approach trying to give the mechanical rules as the expert, okay? For example, if you are measuring something that comes from a wave propagation, there are some rules in physics giving this information, and this is known under the name physics-informed neural networks. Maybe this will play some role in the future.
Yes.
But it needs two communities to come together.
What? Okay. I agree totally. Okay, but what we have now, we have, let's say, we have the rules, we have the law, okay? But what we have, why we need AI and machine learning? We have the law. It's the Newton's law here, okay? The Maxwell law in the static, okay? But this law, for example, that force is analog to acceleration, okay, and mass, okay, it's a law. And this law is valid, but it's valid under the assumptions. Let's have this pen and drop down. There's a law here, okay? Who is the law? That weight and acceleration is that weight minus resistance of the air, okay? This is the acceleration. But which is the resistance? How we can measure this? Because they say, oh, it's not, it's neglectable. It is. If, for example, we have, a rocket, something, flying in the air, okay? How we can measure the wind force at every coordinate? We cannot. So, okay, there exists the law, but because we cannot apply the law, because we have unknown parameters, we need statistics, okay? Because that's why we need statistics, because we don't know the law. And which is the AI? AI are actually statistics. It's more clever statistical statistics modeling. It's not, for example, the standard deviation is something more complicated. But, okay, if we need statistics, then, for my opinion, we need somehow to interpret, to go backward to interpret which is the law. Because nowadays we have the AI as a black box. And because a lot of scientists know the AI, and why we have this revolution? Because some companies, I can say some big research centers have been automated the process. Nowadays we have automated AI toolkits, which is plug and play. So, scientists in health, they say, oh, put an AI and find the correlation between COVID and environment. Okay, but what is the law, as you shall say, behind this? Because this is an arithmetic fitting, an arithmetic conversion. And which is behind the law? We cannot understand the law, and because we have statistics, because AI is statistics, and we have somehow an arithmetic interpolation, we need somehow to find the law behind it as scientists, as engineers. Because without knowing the law, we can't know the assumptions. And which is this model is valid. Under which conditions this model is valid? Because if we don't know to interpret the results, we know that, okay, it is this, for example, is a crack. But why this is a crack, and why this is have happened? Why this modeling? So we need to have some tools to do this, and this is somehow the research challenge. And I don't know if
we can continue the discussion. Maybe we'll come again.
yes.
Thank you. Professor Rocci, this is your turn. Yes.
Good. I will not use slides because I say it's much more freedom to discuss. So basically, the topic is about the relation, the use of machine learning in the field of cultural heritage. A few words about AI and machine learning in general, because one of the hot topics of these days, due to the fact that there are concerns on different sides, typically on the side of ethics, and this was originated, say, 3-4 years ago, with specific reference to the autonomous guide of vehicles and the never-ending problem to understand in case of accident, as our colleague told before, who is in charge for the problem. Is this due to the car builder? Is due to the software developer? This is due to other reasons. And when you have to face the problem of responsibilities and the problem maybe of damages and loss of life, of course, the problem start to get much more serious, much more difficult to be solved. And this was time ago the entry point for the say problems related to ethics in using AI. If we switch to, by the way, it's not yet solved many times, this problem. If we switch to machine learning, actually one of the key aspects is about the, apart from the different, let's say, group of applications in between trained, pre-trained, semi-trained, or without training, the problem is many times the fact that we are looking at a kind of black box. So we don't know exactly what's inside, what happens. Well, it's not so easy to assess the results, to assign a specific level of trust to what is coming out from the system. And so again, there's a number of authorities that are considering the best ways to regulate this sector, both of them, let's say, but much more specifically, actually, the ML sector. We find, for instance, the ITU, the International Telecommunication Union, the European Commission issued a number of, let's say, great papers or studies and even some regulations in order to more or less create a general framework to consider AI and machine and how to pose some trust in them. If we consider the historical application, specifically of machine learning, we have quite a lot of examples. Not all of them are very well known by users, such as the typical get chart, the typical way to recognize if the one facing the screen is a human or a computer system or a bot. And so the idea to read and interpret some texts that are written in strange ways and retype them in a proper one. That is a typical way to train the machine learning system to interpret texts that are not written properly. And this was a long process. One typical example in which we don't see exactly which is the real aim of the application. Of course, a number of things were coming back to our sector were done in the field of image recognition. We all remember probably the old systems to create a taxonomy in the content, visual content in paintings and frescoes. And so the way to assign some specific code to describe the content of a specific document, visual document. Nowadays, thanks to computer vision and much more to machine learning, we have incredible things. I don't know if all of you have the chance to see the TEDx created by Amisod, one of the employees of Google, I think, probably. So did you have a chance to see that TEDx? It was quite impressive. Even if something similar was done some years ago in China. But anyway, what it demonstrates using machine learning is the ability to cluster artifacts very quickly. So to move around this kind of universe of pictures and focus on specific clusters. Or much more impressive, I think, is the opportunity to connect the image captured by video camera to one of the users of the computer and browse the entire set of artifacts, showing the collecting within the collection, the cluster of portraits. The portrait much more similar to this specific pose of the head of the people smiling or not. And this, I think it was when it was delivered some 3-4 years ago, it was quite astonishing. And it was a typical example of the application of such kind of technologies in the field of heritage. I don't know which then is the purpose at the end, but anyway, it's fascinating. The problems in this sector are mainly due to the availability of data, data access, the quality of data, and the problem about the quality of data, I think, is much more general in the field of machine learning, because of course, you need to refer to proper data set with a kind of homogeneous and comprehensive number of information in order to receive as a feedback something that is meaningful. The typical problem, I just back from the ITU and WIS's meeting in Geneva, the typical discussion was about garbage in, garbage out. So how to put out from the data set things that will create a bias in the outcomes of the machine learning process, and how to select the proper data set in order to ensure that the outcome will be meaningful and not something completely sometimes unpredictable. And this is another relevant problem nowadays, because the mechanism of machine learning is able to detect patterns, associations, clusters in very wide range of opportunities or chances. And sometimes what is coming out from the system is even not foreseeable by humans that cannot have this comprehensive view on thousands or millions of data. The typical approach is when you put in some open data, many times not really well selected and characterized by a homogeneous level of quality, and then you completely astonishing. But that's it's another problem that is a general problem. Concerning the outcomes of the use of machine learning in the field of cultural heritage, and if we want even the reverse, so the contribution from cultural heritage back to machine learning, this is not a very positive, let's say, relation if we compare this with other sectors. If we consider, for instance, chemistry or health, where the ability to interpret some exams, to look for DNA association or to look for cells, to compare a number of exams and find out all the correlations and discover things that by hand are very hard to achieve. In our field, the benefits are not so relevant. And many times, I mean, it's a nice exercise, but many times an expert or a group of experts may perform the same activity, I don't mean better, but in reasonable time. Of course, in some fields, the added value is evident. The idea to reconstruct missing part of an inscription, for instance, it works quite well as the idea to give to the system a kind of mosaic of small tiles due to the fragment of a fresco and try to put them together, combine in the best way to recreate the original shape, or even to perform activities that usually were activated thanks to remote sensing. Let's consider, for instance, the underwater archaeology. And so the idea to look from satellite images or from aerial images on some part of the coast in order to identify potential settlements underwater, thanks to the recognition of some signs that are not visible from the ground, but are quite evident if you look from the top. And again, machine learning will be able to better perform in this sector if adequately trained to recognize such kind of signs. So there's, a number of potential applications that are fruitful in this field, but I suppose we are still at the beginning. In the specific field of restoration, of course, we can gather quite a lot of data. We heard before about the use of IoTs or other sensors. And then once we have collected or gathered this huge amount of data concerning a number of, let's say, processes, for instance, on different buildings, different monuments, we can put them in such kind of big quick milling machines and find out potential correlation or understand which are the good treatments and which one did some problems even through time. This morning we heard about the time dimension in many data collections, so the so-called time series. And again, the analysis of time series for a huge amount of data is another good way to fit such kind of mechanism or applications. I think I used my time. I don't want to
Thank you very much.
continue too much. Thank you.
You presented a lot of interesting things, so I could not dare to stop you, of course. Just to mention here that it's a black box and how to interpret the results. I think it is related to what was mentioned previously by Professor Toulamis, or in the previous session, explainable machine learning, or in another definition, cognitive digital twins. Okay.
One thing, sorry, because you called me this one. Actually, there are some studies in, let's say, aim to assign digital identities to AI and machine learning modules in order to certify in some way the quality of the specific module, specific application, even adding a wallet in order to add additional certifications. This trying to solve the problem of trust in such kind of applications. So we're moving toward a transhumanism, having cyborgs. Okay, sorry.
Thank you very much. Next member of the panel is Mrs. Pantimali.
All right. Okay, so I think I will start my brief intervention from what we are about to say. So we have seen a lot of possible uses of AI techniques, but my question is, who is in a way leading this transformation? So who are the actors? Professionals, software houses, or maybe should be public administrations? So like sort of we should implement also the rules regarding how these massive changes in digital approaches and the massive changes that digital transition is giving to cultural heritage as well is affecting the work of professionals, for example. I'm speaking from the point of view of an architect. so I'm not an engineer. And when I deal with the design project, now I have to deal also with different techniques to collect data, of course, but it's up to me in a way. So it's not to me, of course, but it's up to the professional to use the most effective techniques for that particular case. And we are actually lacking, I'm also speaking from the Italian point of view in a way, that even if it has one of the strongest and most articulated regulatory and systems regarding cultural heritage, we are still lacking of somehow a framework regarding the digital strategies and digital techniques that could actually be effective during the design project. So another interesting point that I guess everybody here is addressing is the time dimension. So public administration, for example, are still dealing with, of course, 2D and 3D dimensions data. Not always in an easy way, of course, because they don't have actually access to the raw data, which is quite important when you have to judge and to understand a project. So this is another point that probably should be deal with. But also the most important thing that probably public administration should be taken into consideration is the 4 dimensions of time. So for understand the evolution of a building and to manage in a way the changes of the cultural heritage in general, that is the thing that they have and should protect. It's very important to deal with the 4 dimension, which is time. So analyzing all the data and trying to find a rule to monitor in a systematic way and to read in a statistical way all the data that we can collect from the work of professional, of course, and from digital strategies that probably should be put in action. And so the other question is how public digital strategy, like a biggest framework, could affect the approach to the design project in Italy or everywhere, I mean. So I think that it's an interesting field of research, this one's, how a digital strategy could improve or not the design project and the conservation of the cultural heritage. And of course, if we are talking about which is the most important maybe technology that could be applied to cultural heritage in my particular field, so from this particular point of view, probably is all the AI techniques that could be applied to clash detection. So a standard help the work of people who has to check if things are right or wrong in an automatic way. So when you have a survey, when you have a drawing, when you have something that you have to overlap in a way, find out a method to do it automatically and not manually, and to avoid like the human error, of course. But and also in this field, also the introduction of the hybrid intelligence, I think could be a very helpful tool. Yeah, so I leave the floor.
Okay, thank you very much. I will not enter into the discussion if an architect is an engineer or not. We have similar questions and disputes in Greece as well. But you mentioned a lot of interesting things. Especially the time dimension. If we have a restricted number of measurements, restricted in time, how we hope to recreate the history, the whole history? This is a big question.
Yeah, of course. just to one point, another things that I forgot to mention is that also for what concerns 2D and 3D dimensions in cultural heritage, we still lack of a lot of digital informations. The previous ones are still analogical and not digital. So this is the problem to reconstruct all the history of that building. So, for example, in Italy, they are applying a kind of biggest digital strategy to create a sort of data set of each cultural element. That could be a book, that could be a building, that could be trying to collect all the previous information and to put like a kind of guideline to add the other informations. So that's the point, to collect the previous and also to draw a strategy to collect the new ones, 3D of course, but also 4D ones in a standard and clear way, so that you can keep in stratifying data and informations.
Okay, thank you. Professor Kudos, it's your time to give your opinion and summarize in some sense the discussion.
Thank you. I have some slides to give my opinion and summarize, if we can, please. So I have prepared a brief survey, and then I will provide a report of what was said in this panel today. Very interesting discussion. Let's see, there was before in a previous panel, there were also some annexes by Professor Di Giulio. Here is a recent table of the content that is currently available in repositories all around the world, from Europeana, for example, art, wiki art paintings. These have images and 3D, some of them have also 3D representations. We see that we have million, and this will go, the target of the European Union, as was said before in a previous panel, is about 16 million 3D representations until 2030. So there is a problem here is the searching content, inside content, images, videos, which images, let's say in text has been solved, images, videos, and 3D objects is uncoupled. We have machine learning for the restoration of inscriptions, paintings, archaeological objects, buildings, which is based on geometric info and other internal structure of the objects or the composition or the materials of the objects. We have generative systems for creating plausible versions of cities during time, which, as Ms. Pentimali mentioned, we have to make representations for buildings, for designs, flows, rules, patterns, restrictions, I may add. For all of these, representations are very important in machine learning. So that's another issue. We have machine learning for other applications, graphics applications, which is essential for visualizing cultural heritage. We have the NERF, volumetric reconstructing with NERF, for example, one current issue of research. We have machine learning for animation. We have machine learning for synthetic textures so that we can add, for example, to a building a certain pattern of bricks. Here is for an example for synthetic texture for pebbles. And machine learning for nice rendering, like order-independent transparency, for example, to see the inside of the objects. So key issues. Let's start. Make a sum of what was said in this panel. We have, as Professor Stavroulakis said, we have machine learning for CAD, for finite elements, for image processing, for SHM and other applications. Here in CAD and graphics and rendering, we are still missing some powerful representations for the models. This is a key issue. We have vast collections of items that need more computing power and storage. We have unlimited potential for many fields of cultural heritage, but as Professor Doulami said, we have the problem of explainability, which is a central issue, especially for engineers. Engineers should have responsibility for what they do. That's what engineers should be responsible for, something that they deliver. And the problem here, I may say that is that engineers and scientists that should understand and employ machine learning and artificial intelligence for their purposes and not the other way around. So that's also an issue of education and curricula for engineers and for other scientists. This has to be included in the current curriculum. And of course, the ethics of that's also part of ethics, like Professor Ronzi mentioned. Also, it's important to understand that machine learning and artificial intelligence can reveal patterns that we cannot really find easily as humans, because they may go in many dimensions, multi-dimensionality of data, as Professor Doulami also said. And for example, we may have discovery of underwater or underground archaeological sites from satellite images. That's a very powerful tool that machine learning and AI is offering. So just presenting problems, many problems, but also a lot of potential. Thank you.
Thank you very much. Are there some questions, some further remarks, something we missed to mention during this panel? Yes, please.
Yes, that's an interesting point. We have some years ago there was something that was called procedural modeling, and there were some software like City Engine that was able to have the engineer set some rules about the buildings in that area. And then based on these rules, it could make models of plausible buildings, but just for the purposes of graphics, of seeing the city as it was, as it may be in the future. So you may see in many movies with future cities, City Engine has worked. But now with the capability of, with all the power that machine learning is offering, we can make much more, many more rules, more powerful rules, and more rules with larger scope that hold for, and many more complicated rules for buildings and for. So yes, that's something that has not been explored in depth until now.
Let me make a comment.
Yes, please.
Okay, let's suppose that machine learning somehow statistics and modeling are known functions. Okay, and we have the impact, for example, of a cultural heritage monument on a city, and its health dimension, urban health dimension. For example, how we can design a city to be more healthier for the people. And in terms of healthy, I include also the mental health, okay, and other dimensions. So what we can say is that we have no one discipline, and for example, the engineering, the urban planners, for example, okay. Until now, we design the cities with geometry, okay, but it is geometry. This we need. For example, there is the comfort and health comfort. For example, we need to have buildings, okay, which is sunny, not windy. We need to have cities, we have little distance for the transportations. We have to have buildings with, for example, we have monuments for our mental health. So it's not a one-dimensional thing. And why we need machine learning? Because we don't know the model. How we can simulate, for example, the wind comfort, the health comfort of a city? If we, for example, we have different buildings, height, parks, how we can model this? What is the model? The physics, the law. There does not exist a law. So what we need statistics. We need data, and we need to build simulators, models, in order to have such models, in order to design cities. That's why it's not only computer engineering. It's in general, it's not only civil engineering, it's all science for me.
Thank you. I think the last word, Professor Rocci.
No, it's just the suggestion is apart to have a look at that TEDx. I think it will be interesting to understand the potentialities of machine learning. If you would like to enjoy yourself with some pre-trained machine, the chat GPT, that is a nice application that is able to produce funny things, like to write autonomously some greetings in the Pushkin style or other crazy things. That's all.
Okay, we are leaving you with some homework. Thank you very much for being with us in this round table. Professor Moropoulou, I think you have to introduce Minister.